Hey guys, welcome to the short little extra video for the 8th. Don't look out for the snake. I am having a little bit of trouble breathing. It feels like something squeezing my neck, but I don't see it on the camera. I just see leaves behind it, so who knows. Alright, let's dive right into it, okay? What I want to be discussing today is sort of how studying all these second order differential equations, studying linear systems, and also studying the eigenvalue problem, which is, for those of you who know linear algebra, that's the AV equals lambda V issue that we have. This is all the exact same thing that you're doing. And what changes a little bit is the form in which you're writing your solutions, the way that you interpret outcomes, and those sorts of things. Okay. So if we start with the second order differential equation, okay, let's go ahead and leave constant coefficients, make it homogeneous, just to make some things easier, okay? We have x double prime plus px prime plus qx equals 0. Now, what we normally can do here, we usually find the characteristic polynomial, but let's go ahead and turn this into a system of differential equations by letting y equal x prime, then y prime equals x double prime, which equals negative px prime minus qx, okay? We've done this before to a degree, okay? So x prime equals y, and y prime equals negative py minus qx. I had a real hard time writing x there. And that's a linear system, right, that we should just immediately recognize. So we know that if we have given a second order differential equation, we can transform it into a two-dimensional system of first order differential equations. Wonderful, okay? Now, what I'd like to do is say, well, can I go back and forth between these things? So let's start with a system of first order differential equations. X prime equals ax plus by, and y prime equals cx plus dy. Right? Now, to go from here to describing this as a second order differential equation is not quite as obvious at first. Okay? That very first equation right there does tell me that by is equivalent to x prime minus ax. Wonderful. Random fact of the day. Okay? My video stop? There we go. We can also take the derivative of that expression to get x double prime equals ax prime plus by prime. Now what's neat is I already have an expression for y prime, so let's go ahead and plug that in. So I have ax prime plus bcx plus bdy. Okay. Now, what's nice about this is bdy. Well, I know what by is supposed to equal, and it'll let me get rid of all the y's in my expression, which is awesome. That's more or less the goal. So we will be left with x double prime equals ax prime plus bcx plus dx prime minus adx. Wait for my writing to catch up. Okay. Oh, I found that dang snake. Oh, make that an X. There we go. Okay. Now, to just kind of squish this up and to put it in a form that we're used to looking at second order differential equations, if x double prime minus a plus dx prime minus ad minus bcx. I think I did something wrong here. Yeah, if I move the ad over, it should become positive, not negative. Yeah, that minus sign should be a plus sign right there. I think I fix it, okay? But if we have a second order differential equation, the way that we like to solve it is we write down characteristic polynomials by assuming that x equals e to the lambda t, right? Here, I notice I made a mistake. So we'd get lambda squared minus a plus d lambda. Now this should be turned to plus a times d minus b times c. All that equals 0. All right, yeah, so we've got a mistake here. Change those minus signs to plus signs and we'll be all set. Oh, I should have just re-recorded the video instead of making it last so long. Make it a plus. Make it a plus. Make it a plus. There we go. Now, for those of you who watched the April 6th video, which should be all of you, this should look wicked familiar. This is lambda squared minus trace lambda plus delta equals 0. That's the eigenvalue problem. But it is also how we were finding straight line solutions to first order differential equations. And it's also how we find solutions to second order differential equations. So this is great because in some sense, some real sense